So I want to show you the setup for using a laser to investigate interference effects, single slit, double slit, diffraction gratings, that sort of thing. So the first thing to notice is the school laser. You see it's clearly marked with the hazard symbol, and also the fact that it's a class 2 laser. They're the only ones that are really allowed in school to be used, and they have to lock with a key for health and safety reasons in school. I've got it set up at the moment pointing away from everybody, away down there toward a screen, down the bench there. In its path I have a mounting here, which is a piece of wood with 2 clips, and the slides that you can put in here are the kind of standard slides that we use to investigate these things. Let me show you. This is a single slit. I'm not sure if you can quite see the single slit here, but there is a single slit down the middle of that black, area in the middle of the slide, and you get variance on that. I haven't just got a double slit to hand actually, so I can't show you double slit, but you mount the slits in the holder and set it up as you can see with a clamp stand and a boss and a clamp. And then you position the slit in front of the laser, like so. And once you've positioned it correctly, you then can observe on the screen the interference pattern. This being a single slit, you can see quite clearly there the interference pattern of a single slit diffraction. Now, things you can measure and things you can change in this experiment are, you can measure the distance between the slit and the screen. I'm just using a ruler on the table for that in this particular experiment. You can change the number of slits. So we've got 1. I would normally do young slits, but I just can't put my hand on 2 slits. I'm going to put 3 slits in instead of 1 and see the effect instead of doing 2 slits right now. But the setup is the same either way. There we go. Just need to line that up again. And there we go. There's 3 slits. Quite clearly see the interference pattern there. On a matter of technique, when you've got multiple fringes like this, one of the things you can measure is you can measure the distance between the fringes, either bright or dark fringes. I'm not sure how clearly that's coming out on the video. But instead of trying to measure the distance to 1, I'm going to come in really close actually, maybe that'll be better. So I don't know if it'll focus very well. I'm not sure. But instead of measuring 1 fringe, you measure the whole lot. And then you count the fringes in between. And so a good way of doing that is to stick a sheet of paper on the screen here. This is a sheet of paper just sellotape on. And then to literally mark where you're measuring from on here. So you would mark on just there, I'm measuring from that one there, and I'm going to measure to that one there. And then what you do is you count the fringes in between. So you'd say there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 fringes there. So I would literally make a note of that. And then what I can do is I can come away, I can even move my screen now. I can measure the distance with a ruler between those 2 lines. And then I can divide by 18 to get the individual fringe width. So it's taking an average really over many. If I just show you the effect of swapping the 3 slits out there for a diffraction grating. Here's a coarse grating, it's a coarse diffraction grating with many slits per millimetre. And if I show you the effects of that, you can see the diffraction grating pattern, and then I can move to even more. So I have here a special, another mounted slide with 3 variable diffraction gratings on there. I'm going to put it on the middle one, which is 7,500 lines per metre. Just forgive me while I set this up. So I've just mounted that one in. It's going to need to raise the height a little on this. Put the camera down while I do that. So get it back into the beam because it's a bit shorter than before. So with 7,500 lines per meter, sorry, not per millimeter. Do that properly. There we go. You can see immediately that there are these dots that appear around the place with big fringes now, big gaps between the bright dots. So what you often find with diffraction gratings is that you've had the slit very close to the laser to do single and double slit to give yourself a big picture on the screen. When you do diffraction gratings, you often want to make the slit to screen distance a bit shorter by moving it closer like this, in order to get the just realised I'm going to need to move the clamp stand down a bit in order to get this correctly set up. There we go. And so you can see the fringe pattern there, and then you can investigate the distance between the bright fringes by moving it further closer to the screen and further away from the screen. Now I said to you at the start that the lasers have to be class 2 lasers. It is possible to buy cheap lasers from places like eBay, from places like Amazon, online, and those lasers are often pen lasers that you use as laser pointers, but they can't be guaranteed for use in school. And so that means you can't give them to the students to work with, but it's quite useful to have one every now and again, because if you put the same laser through as well as a different colour has a different wavelength obviously, and then you can quite clearly see the different gaps, in this case the closer gaps between the bright fringes for the shorter wavelength blue light compared to the red light. I must warn you though that these are unregulated lasers if you buy them off the internet, and they can cause blindness because there's no guarantee that the power rating is suitable for use in school. So they're definitely not to be used with students unsupervised, and I certainly wouldn't give them out to any particular student, even a sixth former, nor encourage their use. But for measuring, doing scientific measurement and demonstrating, they are quite useful.